All right. So one of the things that you did on Saturday was Pythagoras theorem, and we know that Pythagoras theorem concerns right angle triangle, right angle triangles. And for those of you who don't know or don't remember, a right angled triangle is one in which there is a right angle in it, a 90-degree angle that we usually denote by this little box in the corner where the right angle triangle, where the right angle is, the 90-degree angle, right? So what Pythagoras theorem says, it relates to it's an equation speaking to the relationship between the lengths of the sides of a right angle triangle. So a triangle has three sides, as you know. In a right angle triangle, the longest side is called the hypotenuse. Right. The longest side is called the hypotenuse. So this side here, I'm going to put that in red. That is the hypotenuse here. Red. So this longest side here is called the hypotenuse, right? So, and I'm going to call, everybody hear me?
Yes, I am.
Yes, miss.
Okay,
Yes,
just
miss.
like talking to myself, that's why. All right, so this is the hypotenuse here. So so if I'm going to just go ahead, I'm going to call the hypotenuse C, and just call the other two sides A and B. So what Pythagoras' theorem states is that the length of the hypotenuse, which we have here as C, the square of it is equal to the square of the sum of the other two sides squared. So C squared, which is the hypotenuse, is equal to A squared plus B squared. So all it is a relationship between the sides of a right angle triangle. So it means that if you have any two of these sides, you're given any two of these sides, then you can go ahead and you can find the other side, right? The side that is unknown. So that's going to be our first revision for tonight. So as I said, we're not going to go into this revision in depth, but just to refresh your memory, so we can have a nice base for our class tonight. So I'm going to give you three triangles and have you use Pythagoras theorem to find the missing side. Our revision is as simple as that. And then I'm going to call on some random people to tell me what they have, because I'm not going to talk by myself tonight. All right, so then this one, that's that, centimeter, 5 centimeters. For this one, you have the, you have 8 centimeters. All right, so I'm going to give you 5 minutes for you to just attempt working these in your books. So you're trying to find the missing side using Pythagoras' theorem, A, B, and C. So 5 minutes, and then we're going to work through it together. I'm going to ask one person to tell me what they have, and then we work from there. Continue. So, um, who wants to tell me what they got for the first one?
4.58 centimeters.
4.58. All right, let's work it and see. I haven't worked it as yet. Anybody? But anything different?
I get 5.83 centimeter.
Yes, 5.83. All right, let's just see what is what. So if we're using Pythagoras theorem, it's saying c squared, we'll just use a different color, c squared is equal to a squared plus b squared. So what I want you to realize is that although the missing, the unknown here is a, and there's an a in the formula. What the formula represents is really just saying this is the hypotenuse, the c is the hypotenuse, and these two a's are the other two sides. So I don't want you to get confused. So I could actually rewrite this. I don't want you to get confused with a and b. I can actually rewrite it to say the hypotenuse squared is equal to side 1 squared plus side 2 squared, right? Forgive my handwriting. So in this instance, the hypotenuse is actually what you are trying to find, right? That is what is missing. The first side is a 5 squared plus 3 squared. Now, it doesn't matter if you had put 3 squared first or 5 squared first, it doesn't matter. So then 5 squared, if you just plug that in your calculator, 5 squared or 5 times 5, you should get 25 plus 3 squared, 3 times 3 should give you 9. So that's your hypotenuse squared, and your hypotenuse squared, 25 plus 9 should give you 34, I think. So now you're here where you have your hypotenuse squared equals to 34. So you need to get just your hypotenuse alone. Because it is squared, to unsquare it, you have to find the square root. And if you square root one side, you have to square root the other side. So you would end up with a hypotenuse, which is what you want to find, equals to, if you just plug in the square root, just touch the square root button on your calculator, and then 34, the answer is 5.8, and it is a side, so it's centimeter, 5.8 or 5.83, that's the answer. So the first person who got 4 points something, do you see where you went wrong?
Yes, Miss, I see where I went from.
Okay, great. Anybody else need any correction or anything like that? Everybody is good for number one? All right, who wants to tell me what they got for number two?
It's like how you put the instead of I never put the hypotenuse here. I put a squared.
It's fine. It doesn't matter. It's just that I didn't want to
Okay.
confuse you. I didn't want to confuse you any at all. It doesn't matter. It's the
Okay.
hypotenuse squared equals the sum of the other sides squared. All right. So everybody is good. So we move on to number two. What did you get for number two? Those who did it,
13.93 centimeter.
13 points something something.
Yes.
I'm going to go off on a limb and say that that's not correct.
12 centimeter.
I don't think that's correct, the 13 point something something, but we'll work it out and see. But just
12,
but just by looking at the triangle, who said 13? Who got
Me
13?
said third.
Who is me?
Oh no. Carry on.
Okay, so this is the
When it
and
this is the reason
this
why
is 12 centimeter.
unless I'm a 13 our out there so 13 centimeter and 5 centimeters. So when
yes,
it's square
yes,
then
yes. But just by hearing the answer, the reason I don't think it's correct, I don't work it as yet though. is because usually your longest side is your hypotenuse, which we already have, right? And that's 13. So you can't have a side that's long
Oh,
and the hypotenuse. So that's why I said it's, I don't think it's correct, but we'll work it. Anybody
okay.
else got anything?
12 centimeter.
5, 12.
12.
All right, now let us work it and see. So it's the same formula. Hypotenuse squared equals the first side squared
Stop.
plus the second side squared. So in this case, we have our hypotenuse, which is 13 squared, because this is our hypotenuse, the one that is opposite to our right angle. So that's 13 squared equals to first side, and it can be any of these. It doesn't matter which one you put first. I'm going to put my 5 first. So that's 5 squared plus b, which is the unknown one, squared. So the situation we have here now is that we need to just rearrange this formula to have b squared by itself since we're solving for b. So all you need to do is to have this moved over here. So you will end up having 13 squared minus 5 squared equals to b squared. 13 squared, if you plug that in your calculator, you should get 13 times 13 is 169.
169.
Good. And 5 squared is supposed to be
25.
25 equals to b squared. Great. And then 169 minus 25
144.
gives us 144 equals to b squared. So we need to get rid of this squared. The way to do that is to square, and the square root of 144, I think, is 12.
12.
So it go
Yes, miss.
12. So the answer is 12, 12 centimeter equals B. So, Kerry, did you see where you went wrong?
Yes, yes.
Okay, you make a little mistake.
Uh-huh.
Yeah, you have to be careful of those because them come at a high price.
Up true.
All right, so we're going to work
Miss,
number the final
miss.
one.
Oh my gosh, delete.
All right, so in this final question, we are solving for, sorry, we're solving for C, which is the one at the bottom here. So we're using the same the same Pythagoras theorem. Hypotenuse squared equals side one squared plus side two squared. So in this instance, we have our hypotenuse here. So we have our hypotenuse is 10. So that's 10 squared equals side one, which is 8. 8 squared plus the second side is the one that we don't know. That's what we're solving for. That's C, right? C squared. That's the formula. So again, we have to get this 8 squared across the equal sign so we can have C by itself, C squared by itself. So we are having 10 squared minus 8 squared equals to C squared. So 10 squared, if you plug that in your calculator, you should get 100. 8 squared should give you 64, I think, yes? And that's equal to C squared. So 100 minus 64,
36.
36,
I still 6.
equals to C squared. And then we need to find the root of both sides. And the root of 36 is 6 centimeters. So C is a 6 centimeter. Pretty straightforward, I think. Do you think it is straightforward? Yes or no?
Yes, miss.
Straightforward enough for question on this? You would have done this already, you know, going through it.
Yes, miss.
Any questions? All right, great. So we can move on then. So the next thing we're going to revise is our trig ratios. Sorry about that. All right, so trig ratios. Why is this not coming off? All right. So looking at our trig ratio now. So again, our trig ratios refer to or is in relation to our right angled triangle. So I'm going to just go ahead and just draw a big old right angle triangle. And of course it's lean because I don't know my hand lean, right? So another right angle triangle, here we go. Now, trig ratios focus or deal with the relationship between angles and sides in a right angle triangle, right? So you should know that we have three trig ratios based on your class Saturday. We have three trig ratios. We have one for sine. Where's my cursor? So we have sine equals opposite over hypotenuse. We have running out of time. We have sine, cosine. Cosine equal adjacent over so hypotenuse, and we have tangent equals to opposite over adjacent. All right. So now and of course here we should have a letter representing the angle. It looks so messy, but I'm going to write it over. Representing the angle, right? So this opposite and adjacent is in relation to another angle in the triangle, which is not the right angle, which is not this right angle that you are seeing here, right? So what it is saying that if it is that you have another angle, say this angle here, which is angle A, if you have the angle at this end, then the opposite and the adjacent is in relation to this angle. Now, of course, your hypotenuse is always your hypotenuse. Your hypotenuse is always the longest side in the triangle, and that doesn't change. But the opposite and the adjacent now, can be different based on where the angle is. So in this case, if we're looking at angle A right here, the side that is opposite to angle A is this side over here. It's opposite, directly opposite it. And adjacent, which is beside, it would be this one right here, right? So in this case, this would be the opposite side, and this would be the adjacent one. And of course, the hypotenuse is right here. Everybody following me? Open your mic and answer. I need to know if you're following or
So
not.
far,
Yes, ma'am.
Don't make no sense me attack and I don't know if you know follow. All right. So if you think about opposite and adjacent, opposite is the one directly across. Adjacent is the one that is beside it, right? If I were to take a different angle now, let us say I'm taking the angle that is right here. This is angle B. And if I ask myself which side is opposite to angle B and which side is adjacent to angle B. So the one beside it is adjacent. So this would be the one that is adjacent to angle B, and opposite would be the one across from it, which would be here. So the key things that I want you to take away here is that when you're dealing with these trig ratios, the opposite and the adjacent are sides, and they are sides in relation to an angle that is not the right angle, right? So in this case, these are angle B that I showed you and angle A. And really and truly, a triangle only has three angles, two other ones from the right angle. So it has to be one of these two, right? So we know that the hypotenuse will always be the hypotenuse, and then you decide which side is opposite and adjacent based on the position of the angle that we are dealing with. All right. So that is what that is the summary, the shortened version of it. So what I'm going to do now, you see, we are just let me